Hello everyone and welcome to this video. In this video, I'll be demonstrating how to configure layer 2 VPN and layer 3 VPN using EVPN VxLAN technologies for the control plane and the data plane. What you see here in the topology is a typical data center architecture where we have two data center 1 and 2 that are geographically distributed. Each data center is composed of a set of leaf switches and spine switches, and the server or the host are attached to these leaf switches here, what you see on the bottom. In my example, PC1 and PC2 are belong to the same VLAN, same tenant, same VLAN, so they need to communicate. So the data center fabric has to bridge these frame that is between PC1 and PC2, and it has to route the frame between PC1 and PC3, PC3 having a separate subnet, so it resides in a separate subnet and separate VLAN. So the data center fabric will have to do routing and bridging for that. I'm using, as you see here, GNS3 as network emulation tool, and I'm using SONiC, the open source network operating system, to configure this setup. So SONiC is a open disaggregated NOS or network operating system that can be installed on a wide range of platform or merchant silicon platforms that can be provided by different leading vendors in the market, such as UFI or EdgeCore. All right. So let's have a look. Of course, everything is pre-configured already, for the sake of time, but I'm gonna go through these through some pieces of configuration, the major ones, so you can really understand and get a clear idea how things are set. So I'm going to start by leaf one. Of course, I've set all the loopback IP addressing and all the point-to-point from leaf to spine IP addressing. I have an MC lag here set up between leaf 1 and leaf 2. I have a port channel here that have two members, two ports, E0 and E1. So here I have an active port channels with two members that can forward the traffic in and out of these interface. I have LACP protocol in place. On the other hand, here in the other data center, I only have one leaf that is connected like a single home connection to this switch. Okay, so this one is off because simply I'm running out of CPU power and RAM, so I had to turn it off. Okay, so first thing to see is the underlay. Okay, so the underlay here, in order to advertise all the IP addresses, all the loopback IP addresses. So if I get a look on loopback configurations, so here this is a loopback, so it will be .1, .2, .3, depending if it is leaf 1, leaf 2, leaf 3. Of course, because it's an MC lag, meaning any of these switches can forward traffic. So I have another loopback that would be loopback 1 that is used as VTAP, VxLAN terminating endpoint. Okay, so this is the same loopback IP address on leaf 1 and leaf 2. If I quickly check here, okay. So these are being advertised by eBGP. So there's external BGP sessions between leaves and the spines. Okay, so that's how I'm advertising all these loopbacks in the underlay in order to be reachable and have my VTAP tunnels established. So here, just quickly, if I check also loopback 1 interface. Into SONiC CLI. Anyway, so we see I have the same IP in leaf 1, leaf 2, and leaf 1 because they are acting as one logical switch. Okay. So if we now have a look on the BGP configuration, just to show you quickly what I'm doing here. So you see router BGP 65001. This is my ID. I'm, of course, I have to set some commands in order to have multipass or ECMP equal cost multipass enabled, meaning the ability for instance, leaf 3 to reach the 10.10.10 loopback, this one, loopback 1, in either by going through spine 2 and then come to this loopback, either by spine 1. So the idea is to have two routes. So if I quickly go to leaf 3 and show you the IP route that I've learned through BGP, and I look for the other end loopback IP. So you see here I have two routes. Okay, one is going through Ethernet 2, which is leading to spine 2, and the other is going through Ethernet 3, which is leading to spine 1. Okay, so this is thanks to these two commands here, in fact, under BGP, best pass, multipass relax, and also maximum pass here, 16. So you can have up to 16 ECMP passes. So under the BGP process, I've activated the BGP capabilities for IPv4 unicast address family, and then I advertise these two routes. So this is a loopback 1 IP address, and this is loopback 0 IP address. Okay, and then of course I establish the peering with these neighbors. So I have to declare the neighbors. So okay, so here first neighbor is on interface 1, so that would be spine 1, and the second neighbor is on interface 4, is reachable under interface 4, which is spine 2. Of course, here the eBGP session will use the interfaces IP address that are configured on E1 and E4. And of course, I've created a peer group, because that's how we do it today. So peer group that will, in fact, include all the attributes that should be used when establishing the peering with these neighbors. So, for instance, remote AS is external, so I'm using eBGP, and capability extended next hop, meaning I'm telling the neighbor not to override the next hop address when he receives the BGP updates. Okay, so if leaf 3 originate a BGP update, it will be received by span 1 and then sent back to leaf 1, and then keeps the original next hop, which is leaf 3 loopback IP address. Okay, and of course I activate the address families IPv4 for now. So for the underlay, everything related to a layer 2 VPN address family is part of the overlay. We're going to see this later. All right. So yeah, of course I can quickly have a look on my let's say IPv4 unicast, and then have a look summary here to just quickly check if I have indeed established a neighbor. So I have two established neighbor on Ethernet 1 and Ethernet 4. It's here and here regarding leaf 1 switch. Okay, so all is good, and I'm receiving prefixes here. So this is same configured on leaf 2, spine, and leaf 3. Okay, we won't go through these one by one. Okay, so next step is to have a look on what is configured on the client side. So once my underlay within the data center leaf to spine is done, we'll have to take care of the client interface. What I say client interfaces are the ports or the interfaces that connects to the servers. Okay, so here I have, as I said, it's an MC lag setup. So switch 1 has a lag interface with two members, E0 and E1. Okay. And here in this setup, of course, I have a resilient architecture with a capability of load sharing. So meaning frames, packets can be distributed over the two links and forwarded. Okay. So I'm using here a VLAN, a switched VLAN interface. Okay. And it's VLAN 10. So let's have a look on interface VLAN 10. Okay. So this interface VLAN, if you like, is stretched over two switches, leaf 1 and leaf 2. Okay. So again, imagine these two switches as one entity. There's an interface VLAN 10 running on top of the lag, okay, or the port channel that has E0 and E1 as members, even though these members are remotely, one is local, one is remote, they are not within the same switch. And this VLAN has a gateway, and this gateway is the same. That's why we call it an anycast address. Okay, so for the host PC1 to reach a gateway, he has to be provisioned with one IP address, which is this one. Okay, so 192.168.154. So quickly, PC1, if I have a look, so it has a gateway, one gateway, and this gateway is configured on VLAN 10, which is again stretched on leaf 1 and leaf 2. Okay, and of course, we're going to see later, this will be part of a VRF tenant 1. Okay, imagine here you would have multiple hosts that belongs to different tenants. So each tenant will have its own VLAN interface, rooted VLAN interface with its own anycast. Of course, for this to work, you would have to configure a couple of interfaces, a couple of commands, like anycast. Let's see what can we find in the running configuration, including anycast keyword. So this anycast address will also have, it's worth noting that it will have also a MAC address, a user configured MAC address that is configured globally on the switches. And these configurations are done, of course, on the two switches, leaf 1 and leaf 2. Well, let me have a look on interface VLAN 10 on the other switch. So you see here, this is what I was saying. You have to configure, you have to enable anycast globally first on the switch, and then you have to configure also anycast MAC address. All right. So these are the two commands that are like prerequisite before setting the anycast under the VLAN interfaces. On the leaf 2, it is exactly the same configuration. So interface VLAN with the anycast, same anycast address. Okay. Now, if we look into VLAN 10, so we see that this VLAN 10 is configured on the trunk that is interface that is port channel 10. Okay, so let's have a look on interface port channel 10, and we see here that we have configured under this port the VLAN 10 to be allowed. Okay, and to be allowed within port channel 10 that it is configured as a trunk. Okay, and of course this port channel is part of an MCLAG domain. That's crucial. Okay, but before going to the MCLAG configuration, just let us have a look. What are the members of the ports that are members of this port channel 10. Summary. Okay, so we see for port channel 10, it is up, and we are running LACP, and here the member is E0, so it is a up. Same thing if we go to leaf 2 and type the same command, we expect to have same kind of output, but with E1 Ethernet 1 as a member port here. Okay. Right, so port channel 10 with Ethernet 1 as member port. Okay, perfect. So now next step is to have quickly a look on the MCLAG configuration. So here it's a bit tricky. We need to find within the running configuration keyword MCLAG domain. It will take a bit some time, but the meanwhile, so let me recap what we have seen. In fact, what happened is that PC1 is connected to switch 1 through a access interface, and then here the switch 1 is configured with 2 uplinks that are part also of a lag interface called port channel 10. Also, we didn't see that, huh? We saw the port channel 10 on the MCLAG setup, leaf 1 and leaf 2, but yeah, you can believe me that on switch 1 we have a port channel 10 with E0 and E1 as members, and these we configured this port channel as a trunk allowing VLAN 10, meaning the frame sourced or received by PC1 are going to be tagged before they reach the leaf 1 client ports. Okay, and then we're going to see how we're going to construct the overlay in order to forward this frame all the way to be bridged all the way to the remote end to leaf 3, and then forwarded down to PC2, which resides in the same VLAN. Okay. In the meanwhile, let's have a look on the BGP here, configuration to explore the layer 2 VPN overlay, configuration. Okay, so I have an output here on the MCLAG first. Let's come back here. So MCLAG domain 1, we define a source and a peer IP. So source IP would be the IP of leaf 1, and the peer IP is the IP of leaf 2. These IP are used for the two MCLAG members to communicate keep alive message, and also to align on their interface status or member port status. Okay. So you can use this communication using a dedicated peer link, which is here a port channel 100 that has E8 port as a member. You can have different ports here within this port channel. And you have to configure a common MCLAG MAC, system MAC, which is common for leaf 1 and leaf 2. Okay, so this is the MCLAG configuration. Now, yeah, so that is the MCLAG setup or the client side setup. Maybe one last check is to have a look on the MCLAG brief command, just to make sure that leaf 1 is able to reach and check the status of its local port, which is E0, and its remote port, which is E1. And sure enough, local and remotes are up and up, meaning both are forwarding traffic. Okay. Second step is to configure, of course, the overlay. So here within the overlay, so under the BGP process, so this is a BGP process 65 002 because we are in leaf 2. Of course, we saw in the underlay we activated or we configured IPv4 or enabled IPv4 unicast, but what's important here is to enable the layer 2 VPN EVPN address family. Okay, so and under that we advertise all VNI, VxLAN network identifier. Okay, so in fact, basically, we need to tell, and of course under the peer group, meaning when you configure the neighboring, you need also to activate this layer 2 VPN EVPN family by adding these two commands under the peer group spine. Okay, so here, what are you telling? What are you saying to the leaf switch? You're saying that, okay, if I receive if some frames out of PC1 on here the interface VLAN interface VLAN 10 and leaf 1 learn the MAC of PC1 host, it will advertise this information to the by BGP, using BGP to its neighbor, and it's gonna send specific type of updates, okay, using layer 2 VPN EVPN family. So that is updates of type 2, okay. BGP route type 2. We're gonna see this later on in some Wireshark capture. It will just simply advertise the MAC of the host. So meaning leaf 3 here at the other end will be aware that of the MAC of PC1, and it will be able to forward traffic to it. But not only that, of course, leaf 1 will say to leaf 3, okay, I know this, I've learned this MAC of PC1, but in order to reach it, you need to use a VxLAN network identifier, or a kind of a label that is that you set, that the user set. Okay, so what's going to happen is that when leaf 3 needs to forward frames to PC1, it will encapsulate the Ethernet frame, tunnel the Ethernet frame with a VxLAN identifier, the one that was advertised by leaf 1. Okay, so of course, to do that, not only you need to configure the BGP part, but also you need to configure the tunneling endpoint. That's why we're going to have a look here on the VxLAN show interface VxLAN. Sorry, show VxLAN interface. Or let's start by having a look on the configuration first before checking the status. Okay, so the VxLAN interface here, I'm in leaf 2. So leaf 2 has, again, this common source IP with leaf 1, which is 10.10.10.10. And this is where the mapping happened, meaning here, VLAN 10 is mapped to VNI 1000. That is the VxLAN network identifier that should be used in the data plane when we need to bridge or communicate information within VLAN 10. All right, the concept is illustrated in this diagram. Okay, so you see here I have leaf 1, 2 on the left and leaf 3 on the right. When a host within that subnet, within that VLAN, needs to communicate with another host within the same VLAN and the same subnet on the other end, okay, it has to go through this layer 2 VPN service using VNI 1000. All right, so here the frames will arrive to leaf 1 as tagged frame with VLAN 10. They will be forwarded here in the fabric, in the data center fabric, but tunneled using VNI 1000. Okay. In fact, to illustrate again, to better understand the concept, what I'm going to do is I'm going to simply, before going through the configuration, show you a capture of the data plane frame. What I'm going to do is I'm going to go to PC1 and I'm going to ping the other end, PC2, which is having the same subnet, but different IP, of course. Then I'm going to ping it. And here I'm going to get some, nothing here because I might be routing through the other link. Okay, so I have the reply on. Okay, so I have let me open those. So I have a reply here. I'm not sure why. Oh, that's RP. Okay. So I have. Well, it happens that here I have the reply on leaf one Ethernet 4. So the reply is here. Okay. So I'm guessing that the reply is here, but I'm guessing the echo request is from here because I'm having two different. So my traffic is forwarded on two different lags here. So I'm guessing. Yeah, that's it. Okay. So in fact, what's happening? That's quite interesting. I'm having the request between on leaf 2 to spine 2. Okay, leaf 2 to spine 2, and then I'm getting the reply from spine 2 to leaf 1. Okay, that's kind of interesting because here I'm using the two members of my port channel, in fact. Okay, the most important is just have a look on the frame. That's interesting. So this is the ECMP using IP source and destination, the Ethernet frame, and this is the encapsulation part. So you see here we are using VxLAN encapsulation with VNI 1000. This is the VNI I showed you, and using, of course, UDP with specific destination port, and then you have the IP, the local IP, and the local Ethernet on the local Ethernet, of course, addresses, but the IPs of the VTAPs. So you see here, communication is from 10.10.10.10, which is the VTAP of this MCLAG entity here, and the destination is 10.1.1.3, which is the IP of leaf 3. That's why the underlay is important in order to advertise these loopback IP address to have these reachable, in fact. Okay. And of course, the reply is the opposite. So I'm sourcing from leaf 3 address to destination leaf 1 and leaf 2 VTAP IP, and same VNI, and here encapsulating the whole ECM frame or packet. Okay. Now, how this will look like on the stop. First, on the configuration verification, in fact. So first of all, I would like to have a look on the show VxLAN remote MAC. Okay, so the remote MAC. So to see what I have learned, what MAC addresses I have learned on VLAN 10. So you see, I've learned dynamically from this other end tunnel, a MAC that is this one. So, and this one is, in fact, it is, minimize here, it is PC2 MAC that is learned by leaf 1. Okay, so if I go to PC2 MAC and you see, if I with show IP, I see that it is in this MAC that ends with 02. It is well learned here. Okay, so this is the first thing. So of course, this is learned by a BGP update. So if I check the BGP layer 2 VPN, EVPN route specific type, because that's advertised by a specific type of a BGP update called MAC IP or type 2. MAC IP. Then, okay, so of course here I'm learning from the other end. Okay, so you see these are all the routes. The coding here is explained as part of the configuration. So these are the types from 1 to 5. So 1, 2, 3. So the third digit is the type of the route, and then you have information about the MAC, the IP, the lengths, etc. So what's interests me is this one. You see that is type 2. That's a MAC address with a 48-bit Ethernet tag 0, and this is a MAC learned from this VTAP. Okay, and you see here the autonomous path. So you see that's the AS ID of leaf 3, then the AS ID of spine 1, and then received by leaf 1. All right, so that's how BGP advertise these MAC. A MAC IP would be this one. So you see here also you have a MAC IP. So sorry, this one. We can see not only we learned the MAC, but we have also the MAC and its IP. That's crucial. That's very important because, in fact, this will allow leaf 1 sometimes to suppress ARP. So when PC1 needs to ARP to know the MAC of PC2, leaf 1 can provide this information because it knows the MAC of that particular IP host. Okay, so that's another command that you configure under VLAN interface VLAN 10 in order to suppress these ARP flooding within the data center fabric. Okay, now we saw how the VTAP is configured. What is left is maybe have a look. I will have a look. I will clear the BGP session just to I will clear all, or maybe only layer 2 VPN, EVPN for all peers, okay, in order to trigger another BGP update. So you can have a look maybe let's filter by BGP here, have a look on how the BGP update look like, okay? So here I have a BGP update, okay, so that's sent by, so if I go to, so next hop is 10.1.3. So this is sent by the IP address of leaf 3. Okay, so these are the interfaces log IP addresses. So next hop is 10.1.1.3. That is a loopback address of leaf 3. And it's a MAC advertisement route or type 2. You see here the digit 2. And you see here you have the MAC. Sorry, this is the route distinguisher. By the way, these are auto-generated by the node, by the VTAP. By default, it's the IP, the loopback IP dot the VLAN. Okay, so that is the MAC address that is advertised. Okay, and it's using VNI 1000. We're going to see the other VNI, why it's used for. Okay, but that will be regarding layer 3 VPN. Okay. All right, and then what other information might be of interest? Okay, same one here. Okay, so this is a MAC IP route. So not only you have the MAC, but also you have the IP. Okay. Here it would be another BGP update, but IP address is not included. So it's only a MAC advertisement with BNI 1000. Okay. So the other is advertising the host MAC and the host IP and how to reach it if you want to route. If the packet is coming out from another subnet, you would use BNI 2000, but it's bridge, it is BNI 1000. Okay, I think that's enough for this video. I hope this was informative to you. Thank you very much and stay tuned. I will post another video that will explain the layer 3 VPN now. Thank you very much.